What if your AI could automatically generate search queries, call tools, and return structured data, all while explaining its reasoning? You'll see how LangGraph transforms raw language models into precise, tool-using agents. First, we'll define a structured output schema that forces the AI to return search queries with justifications. Then we'll bind a simple calculator tool and watch the model invoke it automatically when given a math problem. The pattern is simple but powerful. Augment the LLM, then let it decide when and how to use its capabilities.
Hash schema for structured output. From Pydantic import base model, field. Class search query, base model. Search query, SDR equals field. None, description equals query that is optimized web search. Justification, SDR equals field. None, description equals why this query is relevant to the user's request. Hash augment the LLM with schema for structured output. Structured LLM equals LLM with structured output, search query. Hash invoke the augmented LLM. Output equals structured LLM. Invoke. How does calcium CT score relate to high cholesterol? Hash define a tool. Def multiply a int b, int. Return a asterisk b. Hash augment the LLM with tools. LLM with tools equals LLM. Bind tools, multiply. Hash invoke the LLM with input that triggers the tool call. MSG LLM with tools invoke. What is 2 times 3? Hash get the tool call. MSG tool calls.
This demonstrates the LLM augmentation pattern, where base language models are extended with structured outputs and tool calling capabilities. The core concept involves wrapping an LLM with additional functionality, like schema validation or tool integration, without modifying the underlying model. What makes this distinctive is the separation between the raw LLM and its augmented behavior, enabling cleaner, more maintainable workflows. The pattern works by composing functionality declaratively. Structured outputs enforce predictable response formats using schemas, while tool binding connects the LLM to external functions dynamically. This design keeps the LLM's core logic unchanged while adding layers of control, whether for validation, routing, or external system integration. The result is a modular system where capabilities can be mixed, matched, or swapped without rewriting the base model interactions. This approach matters because it bridges the gap between raw LLM capabilities and real-world applications. Structured outputs eliminate unpredictable text parsing, while tool integration enables dynamic workflows like calculations or API calls. Use this when you need reliability, e.g., form filling, or extensibility, e.g., agentic systems, but avoid it for purely creative tasks where rigid schemas would stifle flexibility. The trade-off is added complexity for the sake of control and integration. Let's break it down.
From Pydantic import base model, field.
Imports Pydantic's base model for structured data validation and field for fine-grained control over model attributes. This enables type-safe schema definitions that enforce data consistency and provide self-documenting models.
Hash augment the LLM with schema for structured output. Structured LLM equals LLM with structured output, search query.
This augments the LLM with structured output capabilities using the search query schema. By binding the schema to the LLM, we enforce that all responses will conform to the defined model structure, ensuring consistent, predictable output with the required fields. This pattern is essential for reliable AI integration, where you need machine-readable results.
Hash invoke the augmented LLM. Output equals structured LLM. Invoke. How does calcium CT score relate to high cholesterol?
This executes the structured LLM with a medical query. The invoke method triggers the model to return a validated search query, object with both the optimized search string and its justification, enforcing the schema we defined earlier.
Hash define a tool. Def multiply a int b, int. Return a asterisk b.
This code defines a basic multiplication tool using a raw function with type hints, which the LLM can use via bind tools. However, the official LangChain docs recommend wrapping tools with the @tool decorator, from LangChain core tools to explicitly define metadata like name description. This improves tool discovery and argument parsing. Without the decorator, the LLM infers the schema from type hints alone, which may be less reliable for complex cases.
Hash augment the LLM with tools. LLM with tools equals LLM. Bind tools. Multiply.
This binds the multiply function as a callable tool to the LLM. The augmented model can now invoke this tool when processing relevant queries, enabling precise computation while keeping the LLM focused on orchestration rather than math operations. This is the standard pattern for extending LLM capabilities with external functions.
MSG LLM with tools invoke. What is 2 times 3? MSG tool calls.
This invokes the tool-augmented LLM with a math question, triggering the multiply tool call. The second line accesses the tool invocation details, showing how the LLM delegates computation to external functions. This demonstrates the core pattern of AI tool use. Natural language input gets translated to precise function calls. Structured LLM augmentation. The patterns shown demonstrate 2 core LLM augmentation techniques: structured output via Pydantic schemas and tool integration through function binding. Structured output schemas like search query enforce predictable JSON responses, but schema validation errors will raise exceptions if the LLM's output doesn't conform. Binding tools like multiply transforms the LLM into an executable workflow node, where tool calls become first-class messages in the conversation.
The schema that describes nothing defines everything.